All right, so today we're going to talk about trig, and so our topic is trigonometry. My handwriting gets successively horrible when I use the stylus. Okay, so we're looking at trigonometry. Does anybody know what trigonometry is?
No.
Triangles.
It deals with triangles. We use trig to find measures of distances and angles that are difficult to find under other circumstances. For instance, I like to be safely with my feet on the ground. I won't jump out of a perfectly good airplane unless it's going down. If I, for some reason, had to figure out how high an airplane was, not that I've ever had to do that, but there are other things that I've had to find the height of that there's no way I'm climbing up it to find the height. And so, for instance, I have a parent coming in that will be flying drones at the football field, his drone, and you're going to have to find the height of his drone at various places on the football field.
Wait, really?
My husband has been known to shoot rockets off at the football field for you to find the height of the rockets. But in order to do that, we have to use trig because you cannot attach yourself to the rocket with a measuring tape and go all the way up and go, it's 100 feet. Okay, it's a little dangerous, right? So, and also consider like the Great Lakes. Has anybody ever seen the Great Lakes? Okay, how big are they?
They're great.
It's like an ocean, isn't it? They're great. The Great Lakes are so huge that there's no way for us to find the distance across the lake, and trust me, there are reasons why we would need the distance across the lake for various reasons. I've never had to know it. Just going to share that one with you, but depending upon your field of choice, you may have had to find, or may have to find, great distances that are difficult. You're not going to go across the Great Lakes with a measuring tape from one place to another to measure the distance. You're not going to see the person on the other side. But what you can do is position yourself at one place and a person at another place and find that distance and know your angle that you are and be able to calculate using trig that distance that was impossible to find. And so trigonometry is really the study of, and this is just really brief. Oh, gracious, that was awful. Look at that T.
I like these names.
So it is the study of triangle measurements. So, in celebration of Star Wars. Oh, well, wait a minute. Hold that thought. Okay, now we'll go. In celebration of Star Wars, there's my lightsaber.
That's so sick.
Is that awesome or what? I know, we had to get the excitement out of there. So in celebration of Star Wars, this is a triangle that you've dealt with in the past in either 8th grade or Algebra 1-2, right? Angle names are with capital letters. Sides are with lowercase baby letters, right? Notice that across from angle A is side A. Across from angle B is side B. Across from angle C is side C. This triangle could very easily have been named HJK. Same thing's going to happen. Across from angle H is going to be side H. So you just have to know that that relationship exists. Yes, same kind of theory. And so we have these, hang on, let me get, there we go. So we have these sine, cosine, and tangents here, right?
Yes.
And we have all of these little ratios that we learned. For instance, these are the important parts. I don't have a highlighter on here. I wish I did. So if I were you, I'd highlight this. So if only. I'm sure there's one, but I haven't found it yet. So, hush, guys. So for sine, the ratio is the leg opposite to the hypotenuse. The hypotenuse is always a hypotenuse. The question is, what does leg opposite mean? And we're going to look at that. Where cosine is the leg adjacent versus the hypotenuse. And tangent is the leg opposite over the leg adjacent. Well, if, I'm going to use two different colors, you're going to use a highlighter. So if angle A is my angle of reference, we are going to find bless you, we're going to find the sine, cosine, and tangent of A using these ratios. So right here, here's my angle of reference. This is definitely the hypotenuse, right? Isn't C the hypotenuse?
Yeah.
So that means that either A or B is the leg adjacent, because these are both legs. Which is the leg opposite A? A. What's the leg adjacent? It have to be B. Adjacent means next door. If I ask,
C2.
okay, good question. She said, isn't it C2? But C is always the hypotenuse. Always. You're right.
Oh,
There are two sides that are adjacent to angle A. One of them is always going to be the hypotenuse. But I'm glad you brought that up. Because oftentimes kids will say C is the side, because and I have to stop myself, because sometimes I'll say side adjacent. Well, technically she's not incorrect, right? So we always say leg adjacent, because that makes a difference between the leg and the hypotenuse. Leg adjacent versus leg opposite. If I change my angle of reference to B, what is my leg opposite B now?
B.
It's now B. It's no longer A. Do you see how they change? And my leg adjacent is going to be A. So let's set up our ratios for A as our angle of reference. That was on my tape. You're so fine. You're adorable and cute. Don't you worry about it. All right.
What?
She burped.
It came out of nowhere.
I just want to point out this is my 7th period class in the little frisky. Okay. So, little frisky. So what's the sine? Okay, so the ratio for sine of A, isn't that opposite over hypotenuse? What's our leg opposite for A? For angle A? Is it A over the hypotenuse, which is C? And so the cosine for A, what is the leg adjacent?
B.
B over the hypotenuse? C. So we've got B over C. And what about the tangent? Tangent is leg opposite, which is A, over the leg adjacent, which is B. So we have A over B. Now, you are going to find the sine, cosine, and tangent of B on your own. So you find sine, cosine, and tangent of B. Are those the ratios you got?
Yeah.
So for sine, we got B over C. Cosine, we got A over C. And tangent, we got B over A.
Wait, why?
Because for sine, for B, for sine is leg opposite, B, over the hypotenuse, C.
No, wait, for tangent.
Oh, for tangent. So tangent is leg opposite over adjacent, right? So leg opposite is B, over the leg adjacent is A. So it's B over A.
I thought it meant leg adjacent.
Oh, okay, no. Leg
Okay, I
adjacent to
didn't
the
see
angle.
it.
Are we all clear?
Yes.
Wes?
On the top, the sine A or sin whatever.
Correct.
Is it B over C or is it A over C?
For sine of A, it's A over C, because for A, side opposite is A, right? Hypotenuse is C. Whereas for B, leg opposite is B. Oh, you couldn't read it?
Yeah.
Okay, gotcha. So we all good? So what is the problem with doing this? What's the problem going to be for you? What's the difficulty for you right now?
Capitals and fractions.
Remembering them, right? Okay.
Yeah.
That is the difficulty. Haven't you been given a way to remember them in the past? Yeah, SOHCAHTOA, right? Here's the problem with SOHCAHTOA. If you don't know how to spell it, is it going to do you any good? Not at all. So if you don't know how to spell it, I'm going to teach you how to spell it. So you guessed, and a lot of you do, and a lot of kids have issues with it, because it's great to know SOHCAHTOA, but if you don't know how to spell it, you have issues. So SO is SOH, CA is CAH, TOA is TOA. What does that mean? Sine opposite hypotenuse. Cosine adjacent hypotenuse. Tangent opposite adjacent. That's what the letters mean, right?
Yeah.
But still, how do I know how to spell it? You're going to love this. I don't want to hear your parents complain about this next thing. I've never had a parent complain about it. I'm a pure as the driven snow girl, just let you know and just say no. So I'm just prefacing everything by that. You ready? Here's how we spell it. My favorite, I'm going to say this 50 times during the lesson because I love to say it. All right, so, S-O-H is some old hippie, hippy dippy, some old hippie. So that's S-O-H, some old hippie, S-O-H, right? So we've got S-O-H. Next one, caught another hippie, hippy dippy. Caught, C for cosine, A for adjacent, and H for hypotenuse. Some old hippie caught another hippie. Yeah, you know it. You know it. Hang on. A good color. How about? Oh, we'll go with that. Trippin'. Yep.
Really?
Tripping on acid. That's the part your parents might complain about. Sorry. That's why I said just say no.
I said it really quietly.
Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. You can't forget how to spell SOHCAHTOA. And so as you're doing your ratios, see, that's perfect for this group because you're all singers, not all of you, but some of you. Okay, so all right, so over here you're going to put sine is some old hippie caught another hippie tripping on acid. Those are your ratios. That's how you know them. Right? You're welcome. So you can't possibly forget these at all, correct?
Correct.
So we're going to do a little bit of practice right here on 1, 2, and 3. A little bit of review practice because this is the easy stuff that you should already know, but we're going to go over it. So you have example 1 here where you know all 3 sides to your triangle. It happens to be a Pythagorean triple that we have studied, correct? We're going to find sine, cosine, tangent of angle A and angle C. So let's start with angle A. So I'm going to circle angle A. You can highlight it in yellow, have your 2 different colors. And then I'm going to find all of those. I normally would write here all of my opposite, adjacents, and hypotenuse, whatever. But I have 2 different angles of reference, and that just gets confusing. So we're going to talk ourselves through it. So first, before I even start, I am, of course, going to say I'm a little sane. Some old hippie caught another hippie tripping on acid, because that reminds me how to set up my ratios. So here we go. So what's the sine? What is side opposite to A? 5. And what's the hypotenuse? 13. So we've got 5 over 13. For cosine, what's the leg adjacent? 12. And what's the hypotenuse? 13. So we have 12 over 13. And then for tangent, what is the leg opposite? 5 over the hypotenuse, or I'm sorry, leg opposite over the leg adjacent. 5 over 12. 5 over 12. Now, you are going to find the sine, cosine, and tangent of C. Yes.
I was gonna say why it's paused. But I was looking at your shoes. What are they?
Okay, so what is the difference between question 1 and question 2? Okay, we're missing a side, right? We're missing a hypotenuse. How can we find it?
9 squared plus 12 squared equals 6 squared.
Great, we're going to use Pythagoras Theorem. So I'm going to let that be little y. So we have y squared equals 9 squared plus 12 squared. Yep. So y squared equals 81 plus 144. Y squared equals 225. How do you solve for y? Square root of both sides.
15.
Y is equal to 15. Let me let you in on a little secret. Whoops, I forgot something on there. Try that again. 15. Look at 9, 12, and 15. Do they all have something in common?
Divisible by 3.
Yes, so if you divide that by 3, you get 3. Divide that by 3, you get 4. Couldn't you have noticed that you had 3, 4, and then isn't that part of a Pythagorean triple that we studied? Wouldn't this one have been 5? And all you would have had to do is multiply it by 3 because we reduced those by 3. All right, so I don't remember where I was after that interruption, but we could have said that this was 5, correct?
Yeah.
And so you could have avoided Pythagoras Theorem by recognizing that you might have a triple, so that's a possibility for some of you. When we find the sine, cosine, and tangent of w, for instance, you can do it one of two ways. So I know that I like to put in my some old hippie caught another hippie tripping on acid. I told you I'd say it a million times. Okay, 50. When I look at my sine, leg opposite is, the original one was 12, right? Over my original hypotenuse is 15. So if I put 12 over 15, what has to happen? You have to reduce it. They're both reducible by 3. So you get 4 over, that's not even a 4, gracious, 4 over 5, right? So wouldn't it be to your advantage if you happen to notice that all 3 of these have a greatest common factor, that you reduce them right away?
Yeah.
And just use the 3, 4, and 5. So when I go to find my cosine and tangent, cosine is leg adjacent, which is 3. My hypotenuse is 5. So can't I just do 3 over 5? And my tangent is leg opposite over leg adjacent. So isn't that 4 over 3? So now you find the sine, cosine, and tangent of x. Okay, so then you do number 3 all by yourself. Find your missing side. Now, if you try to reduce 16 and 34, you're not going to recognize it as one of your Pythagorean triples. Use your calculator. You're going to need it. And I'm going to quietly do it up here, or at least I'll attempt to. Did you get a missing side of 30?
Yeah.
Okay, so it would be to your advantage to reduce all of these by what? What's their greatest common factor between 34, 16, and 30? What are they all divisible by? 2. So 30 divided by 2 is 15. 16 divided by 2 is 8. And 34 divided by 2 is 17. Agreed? Which one is your hypotenuse?
17.
The 17. So you are going to find the sine, cosine, and tangent of M and of L, all by your lonesome. Okay, so all right, here's the deal with the back. We're going to write an equation in order to solve a triangle where you have one angle and at least one side. All I need is one angle and one side, and I can solve any right triangle using sine, cosine, and tangent. The problem is that you have to determine, do I use sine, cosine, or tangent? And so it's going to make a difference. So before we talk about that, here's the formula I expect to see. If I don't see the formula, you lose half credit. I don't want to see the formula after you've solved for part of it. I want to see the following. You're going to choose either sine or cosine. Oh, you can't see it? Oh, hang on. Oh, that says sine. It says sine.
Yeah, it's fine.
They can see it on here. So sine, cosine, or tangent. So write those three down. You're going to choose sine, cosine, or tangent. One of those three. Of some degrees. Now today you're going to know your degree. Equals some ratio, which is the some old hippie caught another hippie tripping on acid ratio. And you're going to have to decide what you put in that ratio. That better? Okay. So you're going to know 2 out of the 3. All right? So how do I tell? So let's look at example 1. Isn't that your angle of reference? What is x to that angle of reference? Is it leg opposite, leg adjacent to the hypotenuse? So you're going to put op there for opposite. And 19? Hypotenuse. So that means we have O and H. What goes with O and H? SOHCAHTOA. Which one? Sine. Sine, isn't it? So because it's so, I know that I'm going to be using sine because of the S. So I choose sine. Don't I know my angle? 28 degrees equals some ratio. Well, my ratio is some old hippie. We already labeled them as opposite and hypotenuse. So my opposite is x. My hypotenuse is 19. How do I know where the x goes? I follow some old hippie. Some old hippie told me where x was. It's hilarious.
Seems like a nice guy.
Some old hippie did. All right. So then you're going to turn this into a proportion. Just kill myself. Can't you put the sine of 28 over 1?
Yeah.
Okay. You know how to solve a proportion. So cross multiply and solve. You get x equals 19 times the sine of 28 degrees. Okay, so remember that it is important that your calculator is in degree mode, so don't forget that. So we got, when we put in our calculator, x is approximately equal to 8.9. This is a side length, so it's not in degrees. It's in some sort of units of measure that we're not sure what it is. Hold that thought just a moment. Oh, I knew it was going to do that. Well, ignore that fact. We'll just have to ignore the sine and cosine that keeps going along with us. Sometimes it does that and it upsets me. Okay, so then this time our angle of reference is 21 degrees. What is x this time?
The adjacent leg.
Yes, it's the leg adjacent. And then the 26? Hypotenuse. And so that means I have A and H. What goes with A and H?
Cosine.
Ka, right? And so you're right, we're going to choose cosine because it's ka, right? You okay? Okay. All right, so we're choosing cosine. Do we know our degree? 21 degrees equals, we're going to use our cot another hippie. Cot another hippie tells us where to put x, right? So adjacent is x, so that goes up top, and our hypotenuse is 26. Can't we turn this into a proportion again? Cross multiply, we get x equals. Please put the 26 in front of the trig function, otherwise it's hard to tell what we're taking the sine of. So pop that into your calculator. Oops. Oh yeah, it's cosine, you're right. Let's say something's up. Sorry. Thank you for saying so. That would make a different answer, wouldn't it? So 21 cosine times 26. What'd you get?
24.3.
Did you use sine or cosine?
Cosine.
What'd you get? And you got, clear out your calculator. Put in 21, and then hit cosine. And then hit times 26 equals.
I did the 20 for the cosine.
Oh, okay. So then you should have gotten 24.3, right? If you round correctly, you get 24.3. Is there questions, issues?
You put it in the wrong order, so that's what's confusing.
Yeah, that's what
Did you
confused
put
me.
26 cosine times 21?
Correct. That's why you have to know your calculator. That's why I'm saying on these calculators, you have to be smarter than the calculator. Some calculators, right, some calculators you can put it in exactly as it sees right here, but these ones you don't. And that's why I said on the first one, you have to put the 21 in first, then the cosine, and then times 26 equals. Every calculator is different. Does that make sense? Are we all good and clear? So when you go home and use your calculator, it could highly be different, right? But you need to be comfortable with mine. All right, here we go. Question number 5. So this time our angle of reference is 33 degrees. What is the x this time? Hypotenuse. That's going to create an issue. What's the 15? Leg. Is it touching it? It's opposite. Yeah, it's only adjacent if it were actually touching right here. So we have OH, which is so. So we're choosing sine. So sine of our degrees, which is 33 degrees, equals, and we're using some old hippie to determine what goes where. Opposite is 15. Hypotenuse is x. So this time our x lands in the denominator. This requires an extra step. So you're going to turn this into a proportion still. Follow? So we're going to cross multiply, but this time my x is on the other diagonal, and please put the x in front. So you've got x sine of 33 equals 1 times 15, which is 15. How are you going to solve for x? Very good. So we're going to divide by the sine of 33 degrees. So this time, when you put it into your calculator, and mind you, these are my calculators, right? So yours could be different. You're going to take 15, hit divided by. Then you have to put in 33 first, then sine, and you have to touch equals. What'd you get?
27.5.
Good. So 27.5 units of some sort.
Is this how Math Excel teaches it too?
They're not as specific as me, but yes. They may not show you how to solve it as a proportion, but yes. I prefer using a proportion method. So then let's look at number 7. 72 is your angle of reference. So you go ahead and set it up, and I'm going to try to be quiet. Try. What'd you get?
8.1.
8.1 is correct. Okay, so to finish the word problem, we've got Jake leaning a ladder against his house. So I am an awesome artist, as you all know. So here is my house. And here is my dog Jojo. We all know how much I love Jojo the pug. There's her curly tail. Okay, Jojo's a little big for the house, but you know, it is what it is. So here Jake has leaned a ladder against the house. I'm assuming that the house is perpendicular to the ground. And if this is the ladder, shouldn't that ladder be 12 feet? Then they've been very clear in here that they are describing the angle to you. So the angle formed by the ladder and the ground. So that's important. The angle formed by the ladder and the ground is 68 degrees. So if you trace the ladder and the ground, I'm tracing the ladder and the ground, you can see the angle that's being formed, and that angle right there is a 68 degrees. So 68 degrees goes in here. And then the question that they have is how far from the base of the house did he place the ladder? So isn't this the distance from the base of the house to the ladder? So that's where we're going to put X. Make a better X. So then I want to label my X as side adjacent because that is the leg that is touching my angle. And the 12 feet is my hypotenuse because it is across from the right angle. And so I have A and H, which means that C, ka, goes with A and H. So I am choosing cosine. So I'm going to set up my equation, cosine. So we've taken the story out of the problem. We're just doing what we did in 1, 3, 5, and 7. So cosine of 68 degrees is equal to, and I've caught another hippie. That tells me where I'm going to place things. So my adjacent is X. My hypotenuse is 12 feet. And I'm going to turn this into a proportion by putting the cosine of 68 over 1. So then cross multiply. 1 times X is X. 12 times the cosine of 68. And now all I have to do is put that into my calculator. Again, depending upon your calculator, depends on how you input it. So the calculator's in my classroom. You would put in 68 first, then hit cosine, then times 12, and then equals. And you are going to round that to approximately 4.5 feet.